In this video, I'm going to explain how you can use multiple offsets on a CNC lathe. Normally on a CNC lathe, the tool number is a 4-digit number. If you look at this tool here, you'll see this is tool 4, which is a 4mm wide grooving tool. And the first 2 digits, the first 04, tells the machine to index, so that will index to tool 4. The turret will rotate to tool 4, and the second 2 tell it to pick up the offset for tool 4. So it looks into my offset file here, so it looks at the geometry for tool 4, picks that up, and then applies that. So that's how that tool 4, it picks up the it indexes, picks up the offset. So let's run this program from the beginning. And I'm going to bring this tool in to a position. So I'm 3mm in front of the job, and I'm starting my spindle, and I'm moving it down to Z-12. Now, because this offset's taken from the front of the tool is 12mm away from the front of the component. Let's just look at the position here. It says there Z-12. If I go into my jog mode and just jog this back a bit, just to show you where it is. So that is, you can see that's Z0 there, and then it's gone back here to Z-12. So it's 12mm using the front edge of the tool. So I'm at Z-12, I'm going to feed in, cut a groove, and then move back out again. What I've done now is I'm going to call out tool 4, but because it's got TO4 12, it's actually going to pick out offset 12. And what I've done, if we go into the offset file, so on tool 4, this is my offset. What I'm going to do is put exactly the same offset into 12. So effectively now, if I call TO404 or I call TO412, it would effectively go to the same position. But I don't want to do that. What I actually want to do is use the front of the tool the first time, and the second time I want to use the back of the tool, which means I can program this groove exactly the same as I would see it on the drawing. And you'll see in a minute that I've got a much better way of adjusting it. So if I add, my grooving tool is 4mm in width. So if I put in here -4 point, and I say input plus, gives me the answer. I'm going to say execute. So now in my tool 12, I've actually got 4mm more on the offset. So it will actually be using the back of the tool instead of the front of the tool. Now, it's important when you do this that you repeat everything else. For example, your radius of your tool, if you are using any kind of compensation to put a rad on or anything like that, or a chamfer, you will need to have the radius of the tool in both 4 and 12, and obviously they will be the same. Now, your virtual nose position will be a 3 in offset 4 because it's a normal right-hand tool, and then in offset 12 it will be a 4 because it's now a left-hand tool because it's working on the opposite side. Now, this doesn't matter if you're not using any compensation or anything to put chamfers on and things like that, but if you are, it's important that this part is repeated. So what's going to happen now is when I actually call this out to move and use the other offset, so if we go back into my program, you'll see that it's now calling out tool 4 and offset 12. Now, word of caution here, this is an index move. So it's going to index to tool 4, but it's already there. Now, the common mistake that people make is that later on they bring this program out again, the tool's in a different station, and they forget to alter the second time the tool's called out, and that would be an index move, so you would have a collision. So if you're worried about that, then what you can do is at this point you could send the tool back to home do the index and then bring it back again, which would be a wasted move, but it wouldn't be a wasted move had you made a mistake. So what it's going to do now, it's going to go to Z-6, but it's using my new offset now, which is 4 millimeters different to the other offset. Let's let it just do that. So it's grooved that and it comes back out. Now, if I now go into my jog and look at my position, you'll see that it says that I'm at -6. If I jog this up to the front of the job, you'll see that now the 0 is there. Can you see where it is? I can't get it exactly on 0, but you can see that the back of the tool is now 6 millimeters from the front of the job. So what that means is it enables me to program this groove. Otherwise, when I come to this position, instead of putting the distance from the front of the part, I would have had to have added on the amount of the grooving tool, the width of the grooving tool, which would be a problem because, as you can see now, what I'm going to do now, I'm just going to reset this and just move my machine back. And I'm going to actually measure what this groove is. I'm going to measure from the front of the component to the back of this groove, and it actually measures 5.936. So that means it's 0.064 undersize. So what I'm going to do is I'm going to go into my offsets and I'm going to go to this offset 12, and in the where I'm going to put in there -0.064 in there, and that's going to effectively move the tool down by 0.064. Now I'm not interested in the other side, but that is actually going to tell me that this is the correct distance from the front of the job. So what I can do with the other side, if I adjust the other side, if I measure from this face here to the front of the job, it's giving me a position of 11.936, and that means that is actually 0.064 out as well. So I need to go 0.064, but this time I'm going to do this on offset 4, because offset 4 is the one that's controlling this part. So I'm going to go -0.064 input. So what I've effectively done now is move one offset that way, one offset that way, and that means that the final figures should now be correct. The point I'm trying to make is that for you, when you come to run this, you're adjusting the two sides of the tool independently. So this means that once you've got this right, you don't have to fiddle with the program, because you would have to actually program it wrong, because if the width of the tool isn't what you expect it to be, you're actually allowing for this in your program. So you've got to keep tinkering with your program, and every time you drag this program out, you're going to have to do the same thing. So it's given me bang on 12 now, but don't forget, this isn't a real machine. This is a virtual machine, and virtual machines do exactly what you tell them to do. So this is going to have adjusted by exactly the right amount, but you can see what I'm getting at here. I'm adjusting it independently. So that's how you use two offsets. And I'm coming back to the program now. Let's have another look at the program. So in my program, I'm calling out the tool index with the correct offset and moving to a position of Z-12, which is the distance from the front of the job to the back of the groove. Then I'm actually grooving it. This could be a lot more complex than this. And then I'm doing my calling out my other offset. But don't forget, I'm right over the job here. Now I'm taking a risk, and that's my choice. I would recommend that you move back to 0 before you do this index, because that's the safest thing to do. So then move into -6. So this is the back of the tool is going to be 6 mil from the front of the component, and grooving again. And that will give you, an easy way to program. You should never have to touch the program. All you should ever need to do is adjust these offsets to get you the right thing. So quick points, The second time you call the offset, send it back to 0, just in case you forget one day and you index over the job. And with your offsets, you must repeat the offset for the second time. So whatever you've got in the geometry for tool 4, you need to repeat in 12 if that's the offset you're going to use. And then all you do there in this line is just add on the width. Well, you want to minus the amount of that tool so that it goes more minus by 4 mil. That's your starting point. You'll have to adjust that. And you need your radius and your virtual nose position. So you put all those in there, and then you can adjust these independently. Don't forget you adjust it on the wear. We're not adjusting it on the main geometry, we're adjusting it on the wear. But we've got two separate things. Now the X's should stay the same. You shouldn't have any variation in the X's because they're coming to the same place. But the Z's will vary.